So we just finished learning how to use the zero product property to solve quadratic functions, and that works really well when the function is in factored form. This is what we did yesterday. Today we're going to talk about using the quadratic formula as another strategy to solve a quadratic function. Now, first of all, to use the quadratic formula, you have to make sure that your function is in standard form. So once you verify that your function is in standard form, which means it looks like this, you have ax squared plus bx plus c all on the same side, you pull out your a, b, and c and plug them into the quadratic formula. So looking at this one, a would be 2, b would be 5, and c would be 3. So if you're going to use the quadratic formula, you're going to take your a, b, and c values and plug them into this. Right there. That is the quadratic formula. It looks a little bit complicated, but we're going to simplify it once we put numbers in there, and it's going to end up being not very complicated at all. So what I'm going to end up doing is I'm going to rewrite this. My two solutions are x equals the opposite of b plus all of this divided by 2a, and the opposite of b minus all of this divided by 2a. So even though this looks like just one formula, it's actually two formulas to give you the two different solutions. Negative b plus all of this, and the opposite of b minus all of this. So when I do that, I get x equals the opposite of b. Now if my b is 5, I'm going to a negative 5 right there. Plus or minus the square root of b squared, so that would be 5 squared, minus 4 times a, which is 2, times c, which is 3, all over 2 times a, which is 2. So I just rewrote this, and every time I saw an a, I put a 2 in. Every time I came across a b, I put a 5 in, or here was the opposite of b. And every time I saw this c over here, I put a 3 in. So I just rewrote this, but I plugged in a, b, and c for my numbers. Now I'm just going to simplify this. So I have x equals the opposite of b plus or minus the square root of. Now to simplify that, I can either do it in my head or I can do it in my calculator. So I'm going to type in, I don't know if you can see that very well here. If I make it darker. There it comes. Okay, so I'm going to type in 5 squared minus 4 times 2 times 3, exactly how I see it. And I'm even going to put this 5 in parentheses right here, because if that were a negative number, I would want to make sure to include the negative. So I'm going to type parentheses 5 parentheses squared minus 4, and then a is 2, and c is 3. So this is exactly what is underneath that square root. 5 squared minus 4 times a times c. And I'm putting my 5 and my 2 and my 3 all in parentheses, because that's going to help me do this if any of those are ever negative. Enter. And that just equals 1. So all of this is really just 1. All over 4. So I have x equals the opposite of b. Now the square root of 1 is just 1. So I'm going to write plus 1 over 4. And x equals the opposite of b minus 1 over 4. Because remember how we said this is really two equations, because one of them is opposite of b, or opposite, or I guess here it's negative 5. So one of them would be negative 5 plus this, and one of them is negative 5 minus this. Well, there's my two equations, plus and minus. So I just chose to separate them at this point. So to simplify then, Negative 5 plus 1 is negative 4 over 4, which equals negative 1. So that's one of my solutions. And my other one is going to be negative 5 minus 1 is negative 6 over 4, which is negative 1.5. So that's my other solution. Okay? Let's do another one. So my A is 5, my B is 16, and my C is negative 84. Move it over so we can see it better. So the first thing I'm going to do is I'm going to rewrite the quadratic formula. And when I rewrite it, I'm going to plug in A, B, and C as 5, 16, and negative 84. So I have x equals the opposite of b, so negative 16, plus or minus the square root of 16 squared. And I'm going to put that in parentheses because that's going to help me if that's ever a negative number. Minus 4 times a, which is 5, times c, which is negative 84. I'm going to make that a little bit longer, stretch over that. All over 2a is 5. And then I just simplify. So x equals negative 16 plus or minus the square root, and I'm going to take my calculator, and I'm just going to plug in what is underneath here to figure out what that is. So parentheses 16 squared minus 4, put the 5 in parentheses, times 5, and then times negative 84. I'm going to put that in parentheses also. And it equals 1,936. 1,936. And so then what I'm going to do, over 10. I'm going to take the square root of that and see if that's a whole number. So second, and then square root, which is just above that squared key right there, right above this x squared is the square root, so I did control and then that key right there. 1936, and it's 44. So I can rewrite this as x equals negative 16 plus or minus 44 over 10. Because the square root of 1,936 is just 44. So now my two equations are x equals negative 16 plus 44 divided by 10, and x equals negative 16 minus 44 over 10. So I have x equals negative 16 plus 44 over 10, which actually equals negative 16 plus 44 is 28 over 10, which reduces to 14 over 5, which as a decimal is 2.8. And the other one is x equals negative 16 minus 44 over 10. So we have negative 16 minus 44 is negative 60 over 10, which reduces to negative 6. So those are our two solutions. So this quadratic function would have two solutions, one at 2.8 and one at negative 6. These are the two places where the parabola would cross the x-axis at. Those are the two x-intercepts. Okay, let's try this one. So A is 4, B is negative 12, and C is 9. Write those there. So we have x equals the opposite of b. Now here b is a negative 12, so we're going to write a positive 12. plus or minus the square root of b squared, so negative 12 parentheses, squared, minus 4 times a, which is 4, times c, which is 9, all over 2 times a, which is 4. So to simplify this, x equals 12 plus or minus the square root of, parentheses, negative 12 squared, minus 4, and then put 4 in parentheses, and then 9 in parentheses. So it looks like that. This is exactly what I have underneath the square root. And it's 0. All over 2 times 4 simplifies to be 8. So x equals 12 plus or minus the square root of 0 is just 0 over 8. So this is an easy one because my two solutions are x equals 12 plus 0 over 8. And that reduces to 12 over 8, which is 3 over 2, or 1.5. And x equals 12 minus 0 over 8, which is the same thing, 12 over 8, which is really just 1.5. So if this is a 0 under here, there's really just one solution. It's the same twice, 1.5 and 1.5. This would be an example of a parabola that just touches the x-axis and goes back up. It doesn't actually go through it to make two solutions when it comes back up. It just touches it at one place. Over here, we have to do a little bit of work before we do the quadratic formula because this is not in standard form. We need to make it so that all of our a, b, and c values are on one side. So I'm going to move this over here with the rest of it. So I'm going to add 4 to both sides. And then I end up with x squared minus 4x plus 4 would equal 0. Now it's in standard form. I have my a, b, and c all on the same side. So my a is 1, my b is negative 4, and my c is a positive 4. So when I write the function, I have x equals the opposite of b, which would be a positive 4, plus or minus the square root of b squared, so negative 4 squared, minus 4 times a times c, and a is 1 and c is 4, get that from up here, all over 2 times a, which is 1. So x equals 4 plus or minus the square root of. Now let's type in what's underneath there to simplify. So in parentheses we have negative 4 squared minus 4 times 1 times 4. So this is just exactly what's underneath my square root symbol here. Just all that stuff. Enter, and that also equals 0. All over 2 times 1 is just 2. So my two solutions are x equals 4, that's just 0, so plus 0 over 2, and x equals 4 minus 0 over 2. Well, that would just go away. 4 plus 0 is just 4 over 2, which is 2. And 4 minus 0 is also just 4, which is just 2. So if there ends up being a 0 underneath there, there really is just one solution. The parabola just touches at one place. If it's not a 0, then you would take the opposite of b value here, this negative 16, and you would add this, divide by the bottom, and then subtract that and divide by the bottom. That's how you use the quadratic formula to solve a quadratic function.